Is your data really your data if it's not self-hosted? If you're hosting something on, let's say, Google Drive, do you own your data or does Google? That's a question that everyone should ask. How is it that I text someone about something and the next minute I'm getting an ad about the same thing? So that's all self-hosting is about, really. How does this work? Why self-host? Because you get to learn about a lot about technical things. You learn almost everything because you do everything yourself. It reduces long-term costs because, let's be honest, we are not paying for Google Drive or anything to get more than 15 GBs of storage. With self-hosting, you can have as much storage as you want, really. And then you can tailor your services to your needs. You can customize it however you want. And the most important part is you have ownership of your data. If I'm hosting something on my own computer, I know that no one else is able to access it, and no one is definitely going to show me ads related to it. So that is all self-hosting is about. No third party is snooping on your data. Basic requirements for a home lab. What is a home lab? It's basically a device on your home that you're using to run or host software. It can be anything. It can be a small single board computer like a Raspberry Pi, and it can be a full-fledged CPU. It's all up to you on how much you want to invest in it, basically. And then again, whether you need a hypervisor or not is also questionable. It depends upon your needs and use cases. But you do need an operating system, which is where Ubuntu server comes in. Ubuntu server is an headless operating system that is specifically designed for server use cases. We'll get to what a headless operating system is in a bit, but let's move forward. What is a hypervisor? First of all, I worship Linus Torvalds, so that's something. But what is a hypervisor? It is a software that you can use to run multiple virtual machines on your device. How many of you know about VirtualBox? We had a talk on LXD yesterday, workshop on LXD. How many of you attended that? So both of them are hypervisors in their own right. And then it allocates the underlying physical computing resources, such as CPU, memory, storage, and gives you a virtualized machine that you can use as your own computer. Every virtual machine has its own operating system and applications which are isolated from each other. So it's more secure. Proxmox. Is this like a spell that they teach at Hogwarts? No. It sounds like one, but it isn't. It's a virtualization platform designed for the provisioning of hyper-converged infrastructure. That's just a very fancy name for virtual machines. It's hyper-converged because all the physical and software resources have been converged into one single virtual machine. Then it's an open source server management platform, and it supports KVM-based virtual machines. Anyone know what KVM is? KVM basically means kernel-based virtual machines. It's basically a module inside the Linux kernel so that you don't need any user space program to run virtual machines. It can run multiple machines, and it is less resource intensive than anything that you're running in user space. Because obviously if something's running in user space, it needs its own resources. KVM utilizes the resources that you have on your machine very efficiently because it's a part of your kernel. Why Proxmox? Because it's very easy to use. It has a very friendly GUI. And it's great for running multiple self-hosted services on the same hardware. You can also use LXD, like we learned yesterday. So LXD is more like if you want to run an entire operating system alongside your virtual machines. And Proxmox is for dedicated machines where you're only running virtual machines. You don't even need LXD or Proxmox if you're just running single software or something on a single machine. You can directly install Ubuntu server on a machine and be done with it. So that's something. Now, what is a headless operating system? What does headless mean here? No GUI basically. It's not a person without a head, but it's basically you don't need a GUI to run it. It's all CLI, command line interface. And it's often used for servers and virtual machines because it's less resource intensive, because you don't allocate resources for graphical user interface. There are no graphical applications. So you don't even need a monitor. Any display is not needed. And what is Ubuntu server? Ubuntu is a very widely used operating system, especially for desktops. But Ubuntu server is something that was designed for servers. And I think even today, most of the servers that are running run on Ubuntu server. And that's because it's very easy to use. It has almost everything pre-packaged and it just runs. There's no special setup or anything that you have to do for it to run. The defaults that come with Ubuntu server run pretty well. This is a very simple diagram that I made on how you actually connect with the internet. So let's say I'm here, but my server is running back at my home. How do I access it? How do I SSH into it? Somebody said SSH, so how do I SSH into it? But I need my IP address, right? What if my ISP is not giving me an IP address? What if it's behind NAT? What if it's behind a firewall? What's FRR? So an easier alternative is just use a VPN. That is what VPNs were designed for initially. So this is a basic diagram. Traffic from the world goes to your ISP, then to your router, to your server. Then you can skip the hypervisor and virtual machine if you want. It goes to your reverse proxy and then it goes to your application. This is the basic flow of how traffic flows into a server and the same way out of the server. So there are two ways you can do this. You can either set up a static IP, but as everyone knows, especially in Southeast Asia, it's very difficult to get a static IP from your ISP. It takes 1 hour to set up a static IP at max. It took me 1 month to get a static IP from my ISP. Exactly, so that's a whole problem which is solved by something known as dynamic DNS. So most ISPs these days provide something known as an IPv6 address, which is public, and it is not behind a NAT. So you can use something like a dynamic DNS to dynamically update your DNS service with your changing IP address. So as soon as it changes, your DNS is notified that the IP address has changed, and it can just directly point to the new address. So this way you don't need a static IP. And then you need port forwarding because obviously you're not going to open all of the ports on your router. What are ports if anyone doesn't know? Everyone knows what ports are, right? What is a port? It's a very simple question. What is a port? A port is a door. It's a geteway. You open the door, you get in. If the door is closed, you can't get in. That's what a port is. And then you need a reverse proxy. So before getting into what reverse proxies are, what is a proxy? Then if you reverse it, that is a reverse proxy. You're basically sending your traffic to one machine, which is then forwarding it internally to another machine. So instead of you doing that to access the internet is doing that to access you. That is what a reverse proxy basically is. And before getting on to how to secure a home lab, let's talk about some reverse proxies. So we have Nginx, we have Apache, then we have something known as CADI. Does anyone know why reverse proxies are actually needed? Load balancing is one of them, but what's the very basic need for a reverse proxy? Okay, your app runs on HTTP then. Okay, that's one use case. The very basic use case for a reverse proxy is, routing. If you have multiple apps running on a single device, and all your requests are coming to the IP address of that device, how do you know which application the request has to go to? Because most HTTP and HTTPS requests will either come to your port 80 or port 443. But what if your application is running on something other than 443? No one's going to type example.com:8080 to reach you, right? So that's why you need a reverse proxy to actually route traffic to the correct application internally. But Once you have set up your home lab, you're connected to the internet. What's an issue here? What's missing? There's a very basic thing missing, which I realized too late. So, one story time. Once I first set up my home lab, the next day I got a notification from my ISP saying I had breached my monthly data quota of 3.3 terabytes. Now, how did that happen? Bots DDoSed my home lab because my static IP was public and I did not have a firewall. So that's when I realized you actually need to secure your home lab. Otherwise, things like this happen. And so how do you actually secure a home lab? You use firewall to block unwanted traffic. If you're using SSH, you don't log in through password. You use something known as private and public keys. You keep regular backups in case something goes to hell. And then you keep your software up to date. This is the very basic outline of how do you secure a home lab. We have seen so many talks in cybersecurity and other things, so you have a pretty great idea of how to actually secure things. So I'm not going to get into very deep of how to securing it, but this is a very basic outline of how to do it. And then these are some commands that you can use to set up a firewall on Ubuntu. Very basic stuff. We deny all incoming traffic, we allow all outgoing traffic, and then we specify what ports we need to allow. Very basic stuff. Fail to ban. Does anyone know what fail to ban is? What use case does it serve? To? Why? No, not blocking ports is the work of a firewall. That is the work of a firewall. Why do we need fail to ban? So if bots are spamming your network, you simply block them through a firewall, they'll keep attacking you anyways. But most bots are designed in a way that if they get a request that they've been banned, they won't attempt it again. So that is where fail to ban comes in. If it detects that someone is repeatedly getting blocked, it will just ban the IP address. And that way, until a certain amount of time, it won't allow any of those requests. And that time is set in the configuration right here. You can set up the ban time, the find time, the maximum retries that are allowed, and then you can whitelist IPs that you don't want to be banned, ever. So this is a very basic configuration of how we set up fail to ban, but the entire configuration is obviously quite big. You can go through the documentation and everything, but this is the very basic of how it works. And then you disable password login using SSH, you set up your public and private keys, all of those things. You disable password authentication, you do not allow a root login. And then these are some FOSS tools that are recommended for self-hosting. So if you're someone like me who likes to go through hell personally, just create your own router. You can use something like OPNsense, OpenWRT, whatever. If you need virtual machines, you can use something like Proxmox or LXD. Then Linux distros, Ubuntu server, Debian, Arch Linux, any of these work. I personally use Ubuntu server on my VPS and it works pretty well. And then for reverse proxy, there are Nginx, Traffic, Apache, and all of those things. But why are we talking about self-hosting? There must be a reason for it, right? What is the need for self-hosting? Because it is your right to have control over your data. And it is your right to use what you want to use, not what is being imposed upon you by cloud providers and corporations. So keeping that in mind, these are some FOSS alternatives to proprietary tools. So you can use Nextcloud if you're highly dependent on Google Drive. For Google Photos, you can use Image, NT. If you're using GitHub, you can use something like GitLab, Forge, or Getty. For Slack, you can use Mattermost, which is also what Ubuntu uses, at least I think so. And then for Zoom, there's an alternative known as Jitsi Meet. It works very well. Then for Spotify, you have Navidrome. If you have CDs lying around at your home, you can just rip them and put them on Navidrome and you can access your music from anywhere. Then for Netflix, you have Jellyfin. Same, you have DVDs, CDs lying around. Just put them on your server and you can access them from anywhere. Then for LastPass, you have Bitwarden, which is a self-hosted password manager. And for Gmail, your Sanity. There's no alternative. Trust me. So what is the one rule of self-hosting? There's one cardinal rule of self-hosting. What is that? Anybody? Any guesses? So the one cardinal rule of self-hosting is this. One does not simply run a mail server. Why is that? Any ideas? It's very difficult to get services to trust you. I've tried this. Took me a month to get services to trust me, and it's still not worth it. So just don't try it. Unless you're insane like me, then you can try it. So this is the one cardinal rule of self-hosting. One does not simply run a mail server. It's just not worth it. Use something like Proton or ProtonMail or something that's better than Gmail. Or just stick with Gmail if you want. But do not run a mail server under any circumstances if you value your sanity. And then these are the real challenges of self-hosting. It takes some time and effort to set up. And then initial purchase for hardware might require investment depending on whether you have some old hardware lying around or not. I myself started with an old laptop that I had. Then I switched to a Raspberry Pi. And now I have a dedicated CPU for my home lab. So it grows over time depending on your involvement and interest in it. And then it requires some technical knowledge, but then it grows as you grow. So it's also very good for learning new things. And then you are responsible for keeping the system running, and Jeff Bezos is your uncle because you're not using AWS. You're using your PC at your home. So Jeff Bezos does not own your data. You do. And then these are some resources that you can use to get started. There's the Ubuntu server documentation. That's pretty good. You have the Proxmox documentation. Then there's an r/self-hosted subreddit where people just spam about self-hosting all day, every day. And then there's a GitHub repository named Awesome Self-Hosted, which has a list of hundreds of free and open source self-hosted tools that you can use. So that was all from my end. Any questions?
Do you recommend using Tailscale?
I use Tailscale myself. So why do I use Tailscale is because I'm here. I want to access my PC back at home. How do I do it? Like I said, I VPN. So now with Tailscale, there's also a problem that your traffic is being routed through their servers, right? I was coming to that. So that is what I use, Headscale. So there's a free and open source alternative to everything. You have Tailscale, which is technically open source. And then you have Headscale, which is a open source implementation of the Tailscale head server, which you can host yourself. And then you can use the official Tailscale clients to connect to it. So it's very easy, but it's not as easy as it sounds. You have to put in the effort. And then any other questions? Practice among the community is to keep 3-to-1 backups, 3 offline, 2 on a separate hard disk and 1 in the cloud. So what I do is, personally I keep 1 backup on the same device that I have Proxmox running on. Then I keep another backup on a separate hard drive. And a third backup is I just rsync it over to my VPS and encrypt it all with GoCryptFS. So it's up to you. You can keep your backups anywhere as long as it's reliable and you know you can get to them when you need them. So the backup policy is all on to you. That is the benefit of using self-hosted services. You can do whatever you want.